During this video, you will learn how to describe microservices and how they can be used for developing applications. Microservices architecture. Your host for this session is Richard Spencer. Let's dive into the concepts of microservice architectures and microservice applications. So, microservices are a style for developing applications. Another key part of what is a microservice is understanding how they work and how they all integrate together. Microservice-based applications call on many internal microservices to do one thing only. From there, they work together to create a wider application. Each microservice will compose a response and return to the request, and this contrasts with the monolithic traditional applications, which have all their code in one principal executable file. It's much harder to troubleshoot a big monolithic application as opposed to an application built upon microservices. And containers are well suited for microservice applications. They're used for modern cloud-native applications. Containers are good because you don't have to worry about any of the dependencies. You can create your image, point your microservice to that image, and then run that image in a container. And as a result, you can spin them up, spit them down at will. And it really jives with the microservice architectures. So some use for microservice architecture, and it's not just limited to these few points, but starting with website migration. So a lot of your monolithic websites can be moved to a cloud-based and container-based microservices platform. Using media content in your applications. Maybe you have users who upload images or upload videos, and these videos need to be transformed into a different codec, or images need to be transformed into a different size, right? By using microservice architecture, you can use queues, and different microservices will perform different actions such as changing the resolution. Transactions and invoices, payment processing and ordering can be separated as independent microservices, and that really gives you some good flexibility. If you can't continue invoicing for whatever reason, you can still continue to process payments through NRS set-aside. And data processing. So a microservices platform can extend cloud support for other modular data processing services. So it's easy to integrate it to things like big data or data processing. Now that leads us into Google Kubernetes Engine. So Google Kubernetes Engine is a way to automatically deploy, scale, and manage Kubernetes in the Google Cloud Platform. So there's two modes of operation in GKE for Google Cloud. You have Standard and you have Autopilot. So Standard is where you actually configure the underlying resources. You have full control over the nodes. You can fine-tune them. You can run custom administrative workloads, and so. Autopilot is just what it says. It's a fully managed solution. It manages your entire cluster. You don't have to worry about any of the monitoring or any of the configuring that goes with it. The GKE Sandbox also provides a second layer of defense using a container-native networking security solution. You have a Kubernetes network policy to restrict traffic with pod-level firewall rules, and you can use private clusters to map to a private endpoint or a public endpoint that only certain address ranges can access. So you have some granularity with regards to networking security. You also have pod and cluster auto-scaling. So you have a full Kubernetes API that allows you to perform four-way auto-scaling with full support for all the release channels and multi-cluster support. You can perform your scaling, horizontal auto-scaling on metrics. One of these metrics could be CPU utilization. GKE offers the ability to migrate to GKE containers. So migrate for Anthos, and GKE makes it easy for you to take your monolithic applications, move them away from your VMs in your traditional data centers, and move them into a container-based application in the cloud. And if you want to get started, there are a ton of pre-built applications and templates that you can use. There's deployment templates. This allows for portability. Right, you can move templates from one region to another zone to another zone. You can share them amongst teams. This simplifies licensing, and it consolidates all your billing. Cloud Run is another service in GCP, which is used for container workflows on a pay-per-use basis. So when you're running containers, you can manage servers. But when you manage servers, there are some issues. You have to provision the servers. You have to scale up and down to meet demand. So you may overpay when more resources are allocated than necessary. So Cloud Run automates most of this process. But you just have to tell Cloud Run where the container is, then press Create. Cloud Run takes in a container built application and deploys it in a serverless environment, so it eliminates need to manage resources for creating and infrastructure, and you just have to continue to write code. Cloud SQL is a fully managed database as a service solution in the Google Cloud platform. Data in the database is stored and processed in the cloud on the infrastructure of a cloud service provider, and access is provided through the console of the command. So the application owner can use the computing power of Google, and they don't have to waste time maintaining their own infrastructure. It's very affordable and much easier to set up than an on-premise database solution. It's also integrated, so you can integrate it into App Engine, Compute Engine. You can use analytics with BigQuery. It's reliable. You can easily configure your replication and backups to protect your data. And by using the database migration service, it makes for easy migrations to the cloud with minimal downtime. Anthos allows you to migrate directly from VMs. You can build, you can deploy, and optimize your applications on GKE. So Anthos is the orchestration and management service and allows you to manage your GKE clusters and your workloads and simplifies your application stack. You have the ability to use policies and security at scale, so you can protect your applications with the integrated security in each stage of the application lifecycle. You define, you automate, and then you enforce your policies. It's a fully managed service. It means it has built-in visibility in all the managing and securing of traffic, and any scaling needed to improve performance is fully managed by GCP. So it's not something that you have to worry about or configure yourself. It has modernized security. So you can develop, build, and run your applications with ease on Anthos, and it integrates CI to CD anywhere. So with Google Cloud, on-premise or other clouds, you can incorporate a continuous integration, continuous delivery service. So while we talk about modern applications and modern application architectures, what are some of the modern architecture needs? We're moving to a more agile and resilient development process. So we need speed. We need to be able to build faster. We need to deploy simpler, and we need to accelerate that workflow. We also need intelligence. We have so much data, we need to use it. So we want to utilize real-time analytics, extract value from the data that we're collecting, and integrate machine learning algorithms to help us fix our applications and create a much better application for our end users. We also need savings, so we need to operate efficiently, we need to scale efficiently, we need to optimize our spending, and we need to instantly scale with demand. So if our demand is low, we need to instantly scale down. So speed, intelligence, and savings is what need to be brought all together for the modern-day architecture. So how do microservices speak to one another? And that answer is using APIs. So when we use these APIs, we can package our legacy applications with APIs as an abstraction layer, and that insulates client-facing applications from any of the back-end services that may change over time, and we can connect to modern interfaces. So our old, traditional applications and services, it still has data that can enable new mobile, web, and voice experiences for our customers. So we need to do this at an accelerated pace. We need to modernize our legacy services using modern RESTful interfaces. Find out how to use contracts, addressing, and application programming interfaces (APIs) to develop microservices apps. Developing microservice apps. Your host for this session is Richard Spencer. In this video, I want to talk about contract, addressing, and APIs for microservices. So the first thing I want to do once I'm in my console is to take note of my project. My project is CLGPCD. We're going to remember that because we're going to look at that and how it uses the project for addressing. So I'm going to go into my App Engine. I'm going to go into the App Engine dashboard. I have an application created, and I just want to walk you through some of the concepts of contracts, addressing, and API. So your microservices, when you run them on App Engine, it could be different services all working together, and they have to talk to each other. So they call each other using RESTful APIs, and you can invoke the microservices in the background by using task queues and the API design tenants that you can take advantage of in App Engine. So one of the most important aspects is to deploy these microservices completely independent of each other. That's what actually makes microservice architecture. So each microservice must be versioned. It must be well-defined with a contract to its clients, and its clients are other microservices. Each service, each new version should not break other parts of your microservice architecture. So let's come into our services. And right now you see, I have one default service. If I click that default service, it just brings me into a hello world. This is version 2 web page. But from here, we can kind of take a look at some of the addressing that's being used. And it's important to note that because before we get into microarchitecture and using microarchitecture, it's important to understand the concepts of how they all speak to one another. So if I look at the official documentation on Google Cloud, it's telling me that services and code versions can be directly accessed. And to address the default service of a default version, use the following URL. And this is what we want to look at. So it's https://project.idregion.id.r.appspots.com. So let's take a look at our application. So here you look at the URL. You can see it's our project ID, clgpcd.ourregionid, UE for US East.r.appspots.com. So that is the default service of the default version. And right now, that version is version 2. But I also have version 1, and that's the non-default code. So let's come back over into App Engine, and let's click the versions button. Now we can see both of our versions. This is version 1. We're not directing traffic to it. There's 0% allocation. But let's just open up the link. You can see this is version 1, but look how the URL changed. Right now, if you deploy that second non-default code, you can see how the URL rules change. So you have the actual code name there. So mine is 2022. This is based on the data that was created. It's just a default name for that version because I didn't actually specify a name to use. Then it goes nice.service.project.yourdefaultregion.r.agentspot.com. So you can see how if we look at the URL for our non-default version compared to the URL for our default version, right? You can see there's a type of difference there. So you can access the default version or you can access non-default versions, depending on what URL you put into your actual browser. Now that being said, every microservice API can also be accessed by specifying different versions. So if you have a front-facing API, you can specify v1. You can also specify v2. There's no need to include a minor API version in the URL because minor API versions by definition will introduce any breaking changes. So what is a breaking versus a non-breaking change? Breaking changes are subtractive. So they take away some part of the request or response document, and that changes the shape of the document, or it can change the name of the keys. So new required arguments are always considered breaking changes, and breaking changes can also occur if the microservice architecture changes. Non-breaking changes are when you add something. So you're adding a new optional argument or a new additional section in a response. These are considered non-breaking changes, and you want to achieve non-breaking changes, right? So I hope this video showed you the importance on using strong contracts, how to address your microservices, and the difference between a breaking and a non-breaking change when you're using a microservice architecture.